Hello and welcome to another A-Level Computer Science video with me, Mr Goff, from MrGoff.com. This video will focus on finite state machines. A finite state machine is an abstraction of the way a machine responds to external events. To be able to be represented as a finite state machine, a machine must always be in one of a finite number of states. It must be able to move between states when triggered by an external event or timer. This is a diagrammatic representation of a coin-operated turnstile as a finite state machine. To start with, the turnstile is locked. If you push on it, it remains locked. If you insert a coin, it becomes unlocked. If you inserted another coin when it's already unlocked, it would have no effect, it would remain unlocked. Once someone pushes on it and goes through the gate, it returns to the locked position. Finite state machines are made up of states and the transitions between them. States are the positions a machine can be in at any given time. We give a special name to the start state. This is the point where we would begin any investigation with our finite state machine. The start state is recognized because it has an arrow coming from outside of the machine into the start state. In this example, you can see that the start state is S1. An accept state is represented by a double circle. The importance of the accept state is seen when we use a finite state machine to track the value of an input and see whether it is valid or not. In this case, we have a finite state machine that's going to determine whether or not a string of ones and zeros in binary is a valid input to our system. Transitions are the lines that move from one state to another. On those lines, you'll see a label that shows what is the input that causes us to change to that particular state. Let's look at some examples of data and see if they're valid. First, let's examine the number 1101. We always start at the start state, S1. If we're in S1 and the input is a 1, it simply returns back to S1, so we stay in the first state. The next digit is also a 1, so it also returns to state 1. When we get the 0, we move from state 1 to state 2. When we get the 1, we go from state 2 and we just return back into state 2 again. We're at the end of our number and we're not in an accept state, so we know that this is not a valid input to this particular system. If we look at the number 1010, once again, we always start at the start state. The first digit is a 1, so we go from state 1 and return back to state 1. The next digit is 0, so we move from state 1 to state 2. After this, we receive another 1. This takes us from state 2 back into state 2. Then we receive the final 0, which moves us from state 2 back into state 1. State 1 is an accept state, as signified by its double circles. This means this is a valid input to this system. Take a moment and try and figure out exactly what the actual rule is that's being displayed here. State transition tables are another way of representing a finite state machine. The table shows for each state the resulting state for any given input to our system. Here we can see that if the current state is state 1 and the next input is a 0, then we will move to state 2. However, if the current state is state 1 and the next input is a 1, we will remain in state 1. We can also see on the next line that if the current state is state 2 and the input is a 0, we will move back to state 1. But if the input is a 1, we will remain in state 2. You will need to be able to read and understand both finite state diagrams and state transition tables in order to take a series of inputs and explain what the result would be. You also need to be able to create a state transition table given a finite state machine diagram, or create a finite state machine diagram given a state transition table. That brings us to the end of this video on finite state machines. Join me in the next video when I'll be taking a look at a special kind of finite state machine called a Mealy machine that also has output. Use the resources at mrgoff.com to help you revise A-level computer science. And until next time, it's bye for now.